Hello everyone. Last week I posted up a video about how to develop an AI trust framework, and we used a little bit of mathematics and developed a heat map that showed that when you have a system where the inherent level of trust for any source of truth, such as a large language model, is below 100%, you can effectively increase your amount of trust by polling numerous people. So we saw the example that if you had a set of people, for example, that you trusted at 80%, you would have to poll, I think, something like 12 people to get to 100% trust of their combined answer. And so it was a really innovative way to start to understand how to apply a statistical approach towards developing trust in a fundamentally untrustworthy scenario. So today I'm going to show you a walkthrough of what that looks like in practice. And so I have a little bit of an example for you here. We're going to walk through it visually and conceptually. And then we're going to get to work and actually make it happen using a variety of different large language models, the top models that are currently available in the market. Now, I'm going to be putting out the results of this test, an actual interactive test, at the CIO-CISO Summit in Ottawa on June 20th. And you can see me presenting there on the topic of AI trust, and you'll see the results there. And then, of course, I'll follow up and share a video that has the results after the fact. All right, let's dive in. So on the screen here, you have an example of how all this comes together. So here, we're going to be using AI agents. To draw a distinction, an assistant is an AI persona that you talk to task to do something in particular. An agent is similar to that, but it talks to other agents, or it references external data sets, or it's able to go and use tools and use tasks. And so the idea of agents is that you can connect them together and you can build a network of capability that far exceeds what one single prompt or interaction with a large language model is capable of. So think of it as a set of dominoes. You can knock down the dominoes. You push the first one and then the rest of them fall in sequence. Well, agents are a similar kind of approach where you can chain and connect them together. So agents are going to be a primary way of how we are able to automate complex tasks and how we're going to be able to achieve something approximating artificial general intelligence in the next few months. So here, let's have a look at this framework. On the left, you have an agent evaluator. And the prompt that we're going to use today is the Alice in Wonderland challenge. So this is a prompt that somebody found. I'll share the link in the comments. And it's an interesting paper that was published, that when you feed a large language model this problem, often it does not do very well. In fact, you may find situations where it's a complete failure. Sometimes if you iterate through the model, which we're going to do, you're going to find that it's able to answer the problem correctly sometimes and sometimes not. So the prompt is: Alice has 9 brothers and N brothers, and she also has M sisters. How many sisters does Alice's brother have? So in order to answer the question, you would have to think of the total set of who we're looking at. And when you use numbers, like if you said Alice has 3 brothers and she has 3 sisters, the language model performs better. But if you give it N brothers and M sisters, this abstraction, it doesn't do very well with that. And so the answer to this, if you want to noodle through it, you could pause it and see if you come up with the same answer. But the answer is Alice's brother has M plus 1 sisters, because Alice is part of the sibling set. So imagine, for example, Alice has 3 brothers and 3 sisters. Well, any one of Alice's brothers would have the same 3 sisters that Alice has plus Alice herself. And so that would be 4. So it would be M plus 1 would be the answer. So what we're going to do is we're going to take the top models available today, and we're going to put them into a parallel processing approach. So we're going to leverage OpenAI GPT-4, GPT-4o, Claude 3 Opus, Claude 3 Sonnet, Mixtral 8x22b, and Mixtral 8x7b. And so that's the big model, and that's the quantized smaller model. And what we're going to do is we're going to ask 5 instances, in this case, of these models the same question. And so these are completely separate sessions. They don't know they're being asked in parallel. And we're going to capture the 5 answers that come out of it. And so that's this aspect. So we're going to ask each model in parallel, And then we're going to ask multiple times in parallel. So there's two kind of aspects of parallel processing here. And that, after round one, is going to give us a results table. And here's where we bring in agent 2. So agent 1 is going to pass the agent 1 is going to be used 30 times to generate a result set table. Agent 2 is going to analyze the outcome. So it's looking at this simply to see if there's a diversity of answers. And so in this case, you might have a diversity of answers being represented by a heat map. And in this case, it's going to try to find the number of instances where there's one distinct answer across the 5 different answers, or there's multiples. There could be an array of different answers. And then we're going to ask it kind of as a preview. We're going to ask it based on, if you have a diversity of different answers, what do you think? We'll be curious to see that if there are divergent responses, whether having more than one to choose from might actually drive on agent 2 to actually reach the right conclusion. So that'll be interesting to see. And so it'll be able to come in and be able to look at the diversity of different things. Now we can read this too and draw some conclusions as to the number of correct answers. And then we're going to go on to the next round. So we're going to go on to agent 3, and this is going to be where we get into agent competition. So you heard me talk about the ensemble approach of having multiple different agents weigh in. Here we're going to have the same large language model evaluate its own set, but then we're going to also have it go round robin. And so you could have OpenAI GPT-4 evaluating Mixtral Mixtral's results and saying, well, what do you think of what Mixtral did? And Mixtral, what do you think about what Claude did? And so we're going to go round robin, and we're going to produce another set and see if we can drive towards any consensus. So if there is a diversity of different opinions and beliefs from what these large language models are seeing, it'll be interesting to see how they react to a dissenting opinion. And then finally, we're going to bring it all down towards a decider agent. So that'll be agent 4, decider. And that agent will evaluate the number of different probable true answers. It'll evaluate any qualitative outcomes that have been attached to it. It'll adjudicate on the outcome, and it will make a recommendation. Now here you have one decider agent. So we're going to have to pick which model that would be. In this case, you could have multiple decider agents and then only take a majority report. And then perhaps if there is no majority report, for example, let's say there's 3 different answers and the decider agents can't decide, you could rerun the experiment again, for example. But in this case, we could have one. Let's experiment with multiple. And then what happens is it comes into a results table. And so you could imagine us running this experiment of the 6 models times 5 questions. We could run that 1,000 times, and we would have a results table of 1,000 where the decider agent would have filled in the outcome 1,000 times. Now here comes the human in the loop. So I talked about applying a statistical analysis to, let's say, 1,000 result sets, but let's leave that aside for now and just say the human looks through and is able to identify that there's still inconsistencies in the outcome, but is able to look at 1,000 and determine a percentage of correct. So we're hoping that the process results in a higher number of correct answers using this method of multi-agent ensemble method approach with multiple different models. And then, so that's the step number 1. And then as the human selects the correct answer, we're going to transit that answer, the correct answer, back into a knowledge set. And therefore, we will know, we'll be able to feed that knowledge set in at step 1. And so let's say the correct answer to the Alice in Wonderland problem is m+1 sisters. We would then have the question, the prompt, and the answer, and a little bit of information about maybe the issue around large language models, perhaps not understanding an algebraic approach versus mathematical approach, for example. We would save that in the knowledge set. And then in future iterations, you would likely expect your confidence to go to 100% for that, because you've either closed a gap in the training knowledge that went into the large language model, or a capacity gap, meaning that the inherent structure of transformers and large language models is not very good at this. And so therefore you have a piece of knowledge that can fill the gap. And you could either use that to fine tune any one of these models, so now it knows that inherently, or you could put it as a part of a knowledge set that can get searched every single time. And what's really interesting about that is you could imagine that there could be a bounty towards identifying these issues running through multiple different models here and then developing a knowledge set that is a layer that sits on top of any large language model that you're using. Think of it as like a knowledge pack. So when you go to deploy Mixtral or Claude or GPT, you would get the truth knowledge set that sits on top of it, and that it would tune away a lot of those inconsistencies and differences. So that's what we're going to build. I'm going to show you how we build this interface, and then we're going to play around with it. I'll show you the outcomes on June 20th at the CIO-CISO Summit in Ottawa, and then I will post up the results after so that you can experiment with this yourself and start to drive towards more trusted, more truthful outcomes, and hopefully drive a lot more business value. So hang tight. I'm going to go code. I'm going to go build this thing, and I'm going to share the results with you in a few days. Thanks.